So hey everyone, this is one short video on STL. So if you'll watch this, you will definitely learn about the STL and you will definitely learn about the advanced topic in STL that we have generally used in competitive programming and some basic programming. So stay with me and let's start the topic. So STL, the standard template library STL in C++ has powerful set of C++ template classes to provide general purpose classes and function with templates that implemented many popular and commonly used algorithm and data structure like vectors, stacks, queue, and more. The STL has four components. Okay, so the first component is container, algorithm, iterator, and we have functor. So in container, this means that this all data and algorithm these process the data and iterator these are used to traverse the data, and we have functor these are functions object. So let's dive into the container first. So container are objects that store data. The STL provides several container types. So first is sequence containers. So we have vector, DQ, list, and array. These are sequence containers. And then we have set, multiset, map, and multi-map. We have associative container, and we have unordered associative container, which called unordered set, unordered multiset, unordered map. And unordered map is one of the most important container here. Even if you with using it you can solve around 50% of the problems in programming world. I mean, just in the context of like just like the program question which generally asked in interview. So 50% time you can solve it using the unordered map, not like even if they ask you like three questions, not that, but yeah, array question. I'm talking about the just array question. So we have example of vector. So what is vector? Vector is kind of array, but the difference is this is dynamic. And let's see what is vector. So we can create vector like this: vector int vector. This is the syntax of vector, and you can initialize 1 2 3 4 5 like this, and you can also add an element to the vector. So like we have pushback function, which generally what does it, like we have vector 1 comma 2 comma 3, and when we push 6, so it will basically shift added in front of 3. So like we have pushback, like we can do like 7, so 7 we added here. And this is basically a iterator that we are discussing. Iterator basically used to iterate the vector. So it equal to vec dot begin. So begin is this term, and we have vec dot l. So it is not equal to vec dot n till the sixth, after the end of 6. So it will be pointing here, and we will be incrementing the iterators, and we'll be printing star it. So it will basically print the value. So like 1 2 3 4 5 till the end. Okay, so we have pop back remove the end of the element. Let's suppose here we have 6. So when we use back dot pop back, so 6 will be removed. So 1 2 3 4 5 is the answer. So x is in the first and last element. We have back dot front, which will print the first element 1, and we have vec dot back, which will print the last element, which is called 5. And vec dot size, we have one more built function which will print the output like the size of vectors. So it is here 5. So common functions of vectors are pushback, popback, front, back, size, and we can use empty, which checks whether the vector is empty or not. So basically we use within the if functions, like if vec dot empty, something like that, we use it. Then we do some conditions, and clear removes all elements from the vectors. So like vec dot simple, we can use clear functions to clear all the elements. So we have insert position value, we can insert in any positions the vector, insert the element at the given positions. We have erase function, remove element at the given position. We have begin and return the iterator to the begin and end of the pointer. So we have iterators. Iterators are used to point to the element of the container. So they are similar to pointer in C++. So using iterator, what we does, as I already told, we use iterator to iterate the vector. So it print 10, 20, 30, 40, and we have iterator in reverse order also. So rather than using vec dot begin, we use r begin. So this is r begin, and we use r dot end. So this way we can iterate in the reverse order. So it means that r begin points to the at last, and r dot r end points at the beginning. Okay, so this is equal to this, and this is equal to this. So it print in the reverse order. So we have some common functions of iterator. We have begin and r begin, and we have advanced iterator command, which is advance the iterator by n positions, like till n position it advanced iterators. And we have distance start comma and return the number of element between two iterators. Okay, so we have stacks, which we called it LIFO data structures. Okay, so stack is a container adapter that operates in the last in first out manner. So example, we have stack. So we have some function as dot push. So we pushing one value, then pushing two, then three, then two, then three. So when we use s dot top, it will print three. It will print three, and when we use s dot pop, three will be moved here, removed here from here. So when we print again element, we will be printing okay top element. So we'll be printing two. So as if s dot empty, still they have one comma two. So it will print stack is not empty, and if you print size, it will give you two. So we have push function, pop, top, empty function to check whether the stack is empty. We have size function to check. Now we have queue. Queue is a container editor that operates in a first in first out manner. So in queue, like this is the library we generally use in queue. Now queue int comma queue. This is a syntax to declare queue. Now queue dot push. We push 10. Then we have rear here and sorry yeah front here, and we have a rear also here. Now when we use 10, 20, when we push 20, so rear will come here. When we 30, then rear will go here. And when we use like q dot front will print 10, q dot when back will print to 30, and q dot pop it will remove 10. So basically it remove like in FIFO manner, so it will remove 10. And then we could print the size, it will get to 20 comma 30 the size. So we have count function in queue, we have push pop front back empty size. So again empty checks whether the queue is empty. Now we have priority queue is a container adapter that operates like a regular queue but order its element according to priority. By default it's max or heap, but it can be customized to min heap using computer. So by default we have priority queue, which is a max heap. Okay, so like we can make a max heap using priority queue. So this is a syntax of priority queue. We push first 5, then 10, then 10. Okay, so yeah, so 10. So 10 will go here. Now we print. We are pushing one. So you should know the max heap maxi property before you should come before you come here. So this is nothing, just like in maxi we store at the top we store the maximum element, then we store its children, and the lower than this and lower than this, and we store the children the lower than this. Basically this is the hierarchy from low to high. Okay, so this is called the massive. So if we print pq dot top, so 10 should come here, and when 10 should come here, which should go here, 5 or 1? 5 will be gone here. Okay, why 5? Because it is greater than 1. So if we pq dot pop do, 10 will be removed, then top element is 5. So this way we can make a max heap. So how we can make min heap? So using comparator functions. So min heap we can use like priority queue int vector int greater int min heap. This is the syntax of custom comparator for min heap. And now we have pushing values and printing like top of the element. When we are printing the top, we'll be getting 1 because it stored the smallest element at the top. Now we are popping, then again we are printing the top, we will get 5. So 1 will be here, 5, then 10. So when 1 will 0, 5 should go there because 5 is smaller than 10. So this way we can customize it. Now count function priority we have push pop top. Now we have empty size. So set and multiset. Set is the associative container that contains a sorted set of unique objects. Our multiset allow duplicate elements. So this is the file include header file for the set. And here we have the some function like insert. So inside we don't use pushback, we use insert functions. So 3 is inserted, then 1 is inserted, then two is so one thing is there, like we have inserted two times, so duplicate element are ignored. So one time when 2 goes in set, again if 2 goes, it says like 2 is already there, so remove this. So we just store one time 2. So when we'll iterate, it will print 3 1 2 1 2 3, I mean in shorted manner. Yeah, so in shorted manner, these are two properties, shorted and duplicacy remove. Okay, these are two properties. So s dot find 2 not equal to s dot rate. This is kind of iterator. So it check if find of 2. I mean it check in the set 1 2 3 whether 2 is present in the set or not till the end. Okay. So if running, so two will be found two, this will print and it will definitely be print when we are storing these values. So we have one more thing called multiset. This is the syntax for multiset. This way we can declare the multiset. We the difference in multiset and set is that we can store duplicate element are allowed here. So okay, so 1 2 2 3 will be the solution if we iterate. Okay, this is an iterator x. So when we are printing x, we will be getting 1 2 2 3. So we have some common function of set multiset. We have insert, find, erase, size, empty, and count value. So insert add element to the set, return iterator to the element is found, erase, remove the element from the set multiset, size, return the size, empty, check whether the set is empty, count, return the number of occurrence of the element. Okay, in multiset. So this is useful in multiset. We don't need to use in set. So we have lower bound and upper bound. So lower bound returns an iterator to the first element that is not less than the given value. Okay, and upper bound return the iterator to the first element that is greater than the given value. So let's see. So let's suppose we have set 1 comma 2 comma 4 comma 5 comma 6, and we have auto it s dot lower bound of 4. Okay, finding lower bound of 4. So we have to find lower bound of 4. So we will be getting 4 as answer. Yeah. So we will be getting as 4 as answer. So what? How we are getting 4 as answer? Yeah, this one 4. So how we are getting lower bound as answer? Because it says lower bound return an iterator to the first element that is not less than the given value. Okay, so it returned it returned the value which is not less than the given value. So here the 4 is already there, so we will return this value. And if we find the upper bound of 4, so what it say upper bound of 4, the iterator to the first element that is greater than the given value. Okay, greater than or yeah, the given value. So just greater than the given value 4, we have 5, so it will return 5 as the output. So we have now order set, unordered sets. The order set element are stored in the sorted order, and also we element also without specifying order. So basically in unordered set we have to go for one complexity when we are basically accessing the element. So in worst case we say like blue moon. In a blue moon we say of n time, like after 1,001 time it will go of n time. So it is very rare case. We don't need to say this. So like yeah, so this way you can declare set, initialize set now and another set. When we are iterating order set, here it will print 1 2 3 4 in a sorted manner. Here will print 3 1 4 2 in order set. So we have map and order map. So map is an associative container that contains key value pair in sorted order based on the key, and order map is similar, but the element are not sorted. So this is one of the most important topic we have. This way we can declare map, like we need to we use kind of key comma value pair inside it, and like like m1 is there and one corresponding we have one. So one is the key and value is one. So two is the key, value is two. This way we can store this, and it dot m dot begin, it not equal to m dot end, it plus plus. So we are kind of iterating the iterator, and we are printing it first, and also we are printing it dot second. So this way we can like use it to print also. This way star it dot first. This way also we can print it the value of it first, and here it will be printing like 1 and corresponding 1, 2 and corresponding 2. This way it will print, and we can check m dot find tone not equal to m dot end. So we can find it like this, and if it is not equal to m dot end, then it say the key to found with value, and m2 corresponding value of 2, like 2 is there, so output will be 2. This way you can use this order map. We have order map. Similarly, we have order map. We can iterate. We will be getting in our order way, like for like the value of 1, then 2, then 3. But if we will insert it in the form of like first 2, then 1, something like that, so we'll be getting in the form of like unordered. So this is we have unordered map. So we have some functions of map, unordered map, insert where key comma value, adds key value where or map, find key. In the iterator, the key is found, erase key, remove the key value pair from the map or map side, return the number of element in the map, another map, empty, checks whether the map is empty, key, then the value associated with the key. Now we have multi-map. This is not generally used in any data structure, but we should know about this also. So a multi-map is an SVT container that allows multiple elements which the same key. Okay, so let's see what it say. So we have multi-map. This way we can inside this multi-map, and yeah, we have mm dot insert. So when we are inserting 1 comma 1, and when we inserting 2 comma 2, and also again we are inserting 2 comma another 2. So in order map or unordered map, we can't insert like 1 comma 1 corresponding to 1 and 1 corresponding to another one. We can't insert like this. Key should be unique. But in multi-map we can insert it, and again we can print this. So this is just the difference. And yeah, we have sorting vectors. So we have sorting like you can sort vector using the sort functions from algorithm header. By default the sort function the element in ascending order. So, but you can also specify custom comparator to sort them in descending order or based on the custom condition. So let's see what sort function is here. So this is the algorithm header file which is need to required for implementing the sort functions, which is an inbuilt library. So vector, we have vector initialize here, and we have used short vec dot begin, vec dot end, and we are printing shorted vector. So shorted vector we are printing. This is the iterator x. So and we are printing x. So output will be 1 1 3 4 5 9. So this way we can print this, and sorting descending on it. So we have vec dot begin, vec dot end. We have greater int. So greater int, this is kind of comparator. Even we can use kind of functions here and declare it above, and we can use inside it some parameter, and we can return in the form of like whatever we want, like descending, ascending, or so on. So basically that comparator is used when we have multiple parameters. When we have pair int comma int. So when we want to do sort in ascending order and descending this in descending this in ascending. So we use comparator functions. Okay. So that's the reason we use customized comparator. So we have common function for sorting. We sort arg begin dot end, sort for the range begin dot end in ascending order, sort begin and comparator, sort in range begin using custom comparator. Sort in array. So sort in array are simple. So similar to sorting vector, you can also sort in the array. So in array, like we don't need to like this is the input function of sort array comma array plus, and n is the size of array. So we can when we print it, we can get the solution and array and greater. Again, this is the comparator. We can also use comparator in the array form. So this way you can print it. Now we have next permutation is the function. So we rearrange the element in the range first comma last in the next lexicographical greater rendition. If no such permutation exists, it rearrange the element as in the lowest possible order. So let's suppose we have like 1 3 like 2 3, okay, 1. So what will be the next permutation of this value? So like 2 3 1 is a value. So next permutation is like 3 2 1 is the next permutation, or 3 1 2. Yeah, 3 1 2 is the next permutation. So it will print 3 1 2 when we use next permutation. Okay. So this is basically like we have vectors, we are using next permutation, vector being vector end. So like we have 1 2 3. Next permutation will be like 2 and like yeah 1 and 3. Like just greater than this value. 1 2 3 just greater than this value is we have 2 1 3, not 2 3 1. Okay, so this is the value it will be written. So we use like next permutation and vec dot picking vec dot, and this is the way we can generate the next permutation again, and you can print it. We will get 2 1 3. So we have built-in some functions. Figure provides several built-in functions for manipulation. Two of the most commonly used ones in built-in pop count and built-in pop count LL. So let's see what is the difference between them. So this function returns the number of set bits once in the binary representation of unsigned integer. Example, built-in pop count. So what it does, we have x is equal to 29. So binary number is 1 1 1 0 1. So number of set bits in x is we have basically 1 2 3 4. We have set. So what we do int count, built-in pop count, we pass this value with within the parameter, and when we print the value of x, we will get 4 as output. So this way we can use built-in pop count. And similarly we have built-in pop count LL. So LL demonstrate the L long. So if we have X value very long, so we can use built-in pop count LL, and it will get like how many set bit are there. So it will print it. So we have summaries. So STL component container vectors. So these are STL components. So container, container vector, stack, queue, priority queue, set, multi-set map, order map, multi-set, algorithm sort. We have next implementation, iterator, and functor. We have vector commonly contained with various functions like pushback, popback, etc. Stack, we have default structure, queue, we have C4, priority queue, we have allow custom ordering, set, multi-set, we have store. We need duplicate element, map on when we have k value pair without ordering, sorting using sort for actor array. Next function we arrange element in the next function like geographical order built-in function like built-in pop count and built-in pop count LL. So these are some functions. So these are some problems in vectors. So you can refer this after the learning of all the vectors, containers, functors, and algorithm. So you can like go through this. These are some pretty good questions for practice. So thank you.